Hi, good evening. This is Bala. So, hope you all fine. Until last class, we have discussed about digital to analog converter, and also we have discussed three signals out of the four signals which I have already mentioned. Okay, so I have finished square wave, triangular wave, and ramp wave by using an ARM controller. Now, what we are going to do is we are going to check the result for sine wave. Okay, so what you have to do is go for K, go to your just create a project, create a new file, that is sinewave.c, then write your program, save your program. Okay, so here comes the process. First of all, what you have to do is you have to choose what controller you are using. I am using LPC2148. So next one, after that I am using a math operation. I will be saying why I am using this function, because we in our previous project we have not yet used this math function. This is the first project we have using this math function. Okay, so then again an integer I, which I used in my for loop. Then I have to open my program. So like in our previous projects in DAC, I have again chosen my pin select 1 and 8th pin, that is nothing but 19th and 18th pin as 10. If my 19th pin and 18th pin as 10, then it belongs to my A out. Okay, to be again saying that my value is 0008000. So all the values are 0 except this value, that is nothing but 1000. But as far as my pin select is concerned, I should select only the two pins, so 18 and 19. So the value is 10. If that is my 19th and 18th pin, if the value is 0001 1011, there are four conditions, my value is only 10, so it will be acting as an A out. Okay, again going to program. So this is been initialized. Again I am declaring a local variable, that is nothing but value, because I have used in my program as value. So I have declared my variable. So if my controller is in true condition, a for loop is executed and it starts from 0 to 360. So here is a small logic. For that we have to just see our sine wave. So a sine wave which starts from any end, it may be from 0, that is as I already said, my analog voltage is divided starts from 0 and ends with 3.3 volt. So I am taking a centermost value, that is 1.65 as a middle value. So it starts from a middle value and goes for high value, then again back to a low value 0, then again back to a high value, that is mid value 1.65. So starting from 1.65 and ending with 1.65 will give a complete, that is one positive half cycle and one negative cycle will give a sine wave, complete sine wave. So the total degree of this is nothing but 180 plus 180 is nothing but 360 degree. So what I am going to do is I am going to divide my program into 360 halves, and I am going to run my program in 360 scenarios one by one. Okay, so that what I have done is I am incrementing my value, that is from first value is 0 degree, then 1 degree, 2 degree till 360 degree to complete a complete sine wave. So my program starts from 0 and it goes till 360 degree. Okay, then what I am going to do is I have written a function, because I am generating a sine wave, so I can't straight away mention my value, that is sine of theta. So there is a formula for converting your signal, that is digital signal, into an analog sine wave. That is nothing but a sine function. The formula is sine of 2 pi t by capital T. Okay, so sine of 2 into pi into t by t, this will be your formula. So what and I have also mentioned two more values on my program. Okay, so I'll be using this formula here for verification purpose. Okay, so sine of 2 pi t by t, this t is nothing but the total time period. As per my diagram, the total time period is nothing but 0 to 360. So the total time period takes to complete is 360. This is the time period, that individual time period, that is nothing but your value. It starts from 0. First it will be as 0, then it will be 1 2 3 4 till 360 will be goes on increasing. So pi is nothing but 3.14. okay, so this value comes from multiplying this value, that is 2 into 3.14 divided by 360. You can use your calculator, go for your programming mode, scientific mode. My value is 2 into my pi value 3.14, that is nothing but 6.28 by the total time period t is nothing but 360. So the value is 0.01744, that I have taken as 0.01745. you can use 4 also, no problem at all. Okay, just you can save that. Then I have used two more value here. This is nothing but this is used to make your sine wave visible and also to reduce your aliasing effect. I have taken a complete value with this. So for this, what I have to do is I should check my value. So I have generated an Excel sheet. So first value is 0 and my formula is 512 plus 511 into sine of that function. Okay, 5.44. okay, just I have called that value. Okay, so if my time period is 0, then my value will be 512. If it is 1, it is 520. So what I have to do is, there are two values in a sine wave, that is starting from 0 to highermost value 3.3. if my value is 3.3, that is nothing but my output value is 1024 by 1024. It is 1024, that is high value is 1024 by 1024 into 3.3 will be 3.3 volt. If it is 0 by 1024 into 1000 into 3.3 will be 0. So there are two main values are here. So for that purpose I have used that. Okay, so now going back to your Excel sheet. So it starts from 0 and n tills 360 degree. Okay, so my last value is 509.557. so I have to check whether my limit has exceeded my limit. So I have just started largest to smallest. You can check that my highest to highermost value is 1022.99, that is nothing but 1023. as I already said, my ADC is nothing but this is a 10 bit ADC, so 2 power 10 is nothing but 1024. It starts from 0 to and ends with 1023. So I have used to make this function and to make my output visible, I have done this. Okay, I have done two values, that is 512 plus 511. You can add any number of values with this. You can also use some other values. What will be happening is the output which you are getting will be decayed. So that will be, we can see in our output. Okay, first just add that. So my first value, if it is I is 0, 0 into this value will be 0. So sine of 0 will be 0. So 0 into 511 will be 0. So my output will be 512. Okay, 512 will be the centermost position. So like that it goes on. This value will be moved to my digital to analog converter register. So control register. Once it goes gone to the register, you can see that output. Just to save your program, add your program, that is sinewave.c, add. Okay, then run. So I have got a new line should be added to remove this error. Okay. Okay, no problem. Okay, it's 0 warning and 0 errors. Then I should go for my debugging mode, setup, and then I should add my A out pin as my output pin. Then close here, save and run. I think you are getting your output. So stop your program. Then you should check your value just in your program. See, you are getting the value. So click here for your maximum value, that is 3.29355. that is nothing but 3.3 volt. My maximum voltage is 3.3 volt and my minimum voltage is you can go for auto. Okay. Is 0.00 is nothing but 0 volt, my lowermost value. Okay, my lowermost value is nothing but 0.0, that is y is nothing but 0, and my highermost value will be 3.29. okay. So another one thing, if I reduce this value, what it happens is nothing but the value which you are going to get your get on your amplitude gets decreased. For that, again you can go to your Excel sheet. Okay, just reduce this. If I am using as 300, okay, my maximum amplitude is 811 and my minimum amplitude is 212. okay, so go back to your program and use as 300. 300. okay, run your program, build your project, go to your debugging mode and click run button. Stop your program. See, the amplitude gets decreased. In our last output, when it is 512, 511, what you got is your output as 3.295. Right now you got only 2.6 as your maximum amplitude, and your minimum amplitude is 0.6. So the overall amplitude from here to here is nothing but 2 volt, right? But in our previous sample we have got 0 to 3.29. That is no problem at all. This is nothing but it is used to decrease your amplitude alone. You can use any value between that. If you neglect these values, then there may be a problem, and it leads to non-output of your sine wave. Okay, so thanks for watching.